Hello, so this is the next video in the series and we are now on test number 26. So this is again graph B, the one which doesn't have direct connections or paths, and we're going to do our start and end nodes as A and C respectively, and our expected result should be that there is no such path which exists. So if I come here, which one was it? Oh, sorry, my mind's gone blank. Bellman Ford. So, 3 nodes, and this was 5, 0, 0. Now, our start node is A, and our goal node is C, and this was an undirected graph, and we have that a path isn't found. So that's good. So we can tick that off. So Bellman Ford can work with no direct connections and with a normal graph. But again, as we did with our other optimizations, I think it's worth checking out whether for the same graph we get a shortest path of 5 when we go from A to B, because we should really. So let's have a look. Yeah, and we do. So that's good. So that's fine. Now moving on to test number 27. This is still Bellman Ford, and now we're checking that the algorithm can handle negative edge weight cycles. So this is for an input of graph F with any start and end nodes. So what does this mean when I say negative edge weight cycles? If we have a look at graph F, this is what graph F looks like. You can see that A to B is -5, and it can go both ways. So if I'm finding the shortest distance from A to B, well, I can go from A to B, but then going back from B to A gives me -10, then -15, then -20, and our shortest distance from A to B would, in essence, using Bellman Ford, be just -infinity. It would be so small. And obviously, because of the nature of the way Bellman Ford works, we can't allow such graphs in the system. They will cause damage, they will cause the system to crash. There is a greater explanation on why negative edge weight cycles are discarded, and I think that's in the analysis when I research each of these optimizations. So if someone inputs graph F, we need to tell them, I apologize, that's my clock in the background. If someone inputs graph F, we need to, basically the system needs to say that, no such path exists or could be found. I think a thing to consider is also with any start and end nodes. So if we try from A to B and A to C as our 2 examples. So if I go on Bellman Ford, so we have 3 nodes. Edge AB is -5. Edge AC is 2, and edge BC is also 2. So our start node is A and our end node is B. There is a path from A. This whole graph is undirected, there aren't any arrows, so we can just put a 1 for each of these. And so it says the graph has no shortest path because it contains a negative edge cycle. So, it said we can't find a shortest path. There is no shortest path because there's a negative edge cycle. So with an unconnected graph, it was that the path isn't even reachable. Here, we can't find it. Now, if I do A to C as well, we should have the same output. So A to B, -5. Because it contains a negative edge cycle, it's not a valid graph. So A to C, A to C, again it's an undirected graph, so this isn't a problem. And yeah, so we have the same output. So our system can deal with graphs which aren't made for Bellman Ford, so we can pass that. Now we move on to prims. So it's been 4 minutes. So we have tested all the shortest path optimizations. Okay, now we're moving on to the minimum spanning tree. optimizations. Sorry. So let's see what test number 28 wants. So this is testing prims, and it says check for graph G inputted. The algorithm shows the minimum spanning tree and the weight of the minimum spanning tree, and this is what we should expect to get. So graph G looks like this. It's got 5 nodes this time, and let's input it into the system and see what we get. So prims, so we have 5 nodes, and edge AB has a weight of 7, edge AC has a weight of 0 because there is no direct edge, edge AD has a weight of 6, and edge AE has a weight of 5. Alright, now BC is 5, BD is 6, so BC is 5, BD is 6, and BE is 0. CD is 8, and CE is 0. DE is 4, and that's the last one. So this is our result. Let's see what we should have expected to get. So the cost of the minimum spanning tree is 20. Well, total minimum cost 20. The edges DE, EA, DB and BC. So DE, well, edge ED is basically edge DE, so that's fine. EA, so again AE is EA, DB again, and BC. So it doesn't matter that they've been output in a different order to the one stated in the expected result, and it doesn't matter that it's AE instead of EA. It's the same edge, the same edges that we've got, so that's a pass. Okay, now test number 29. Now the thing is with the minimum spanning tree optimization, the minimum spanning tree algorithms, is they work with graphs that are connected, right? So if we have a graph that is unconnected, then we can't find a minimum spanning tree, because a minimum spanning tree needs to have all the nodes. And if you think about graph B, which we were looking at earlier, well, you can't form a minimum spanning tree because you need to include node C, but there is no way to include node C. So we need to reject any unconnected graphs that are passed into prims. So let's see if the system does that. So we have 3 nodes, edge AB is 5, and then AC and BC are 0. And it says the graph is unconnected, hence a minimum spanning tree cannot be found. So the correct statement should be output stating that due to the graph being unconnected, a minimum spanning tree cannot be found. Let me just check the time. Okay, so that's good. So that works. So it rejects any graphs which don't fit the criteria for prims. Now, Crisscross is also a minimum spanning tree finder. It just works in different ways to prims. It sometimes gives different minimum spanning trees, but the weight of the minimum spanning tree found by prims and Crisscross will be the same. And for Crisscross, we're using the same graph. We're still using graph G. We have 2 minutes to spare, so I'm not sure how quickly I can do this. So this video might cut off, and I will apologise for that in advance. 5 nodes. Let me just, so 7065, 7065, then 560. I am slightly cautious of time here. Yeah, so less than a minute left, so I will see you in the next video, and we will continue to carry out our Crisscross testing.